I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll discuss inverse functions with a grade 8 student. Hi Abhinav, how are you doing?
I'm good, sir. How are you?
Very good, very good. So how had been your Christmas holidays?
Yeah, it's good so far.
Very good. So today, what do you want to learn?
More practice on inverse functions.
The inverse functions. Good topic
Yeah.
you selected. We did talk about it a bit earlier. Now, what I'll do is kind of review a part of it, and then we'll move on to some difficult, I should say, challenging questions for you, since you are in grade 8, right?
Yeah.
Here, inverse function we teach in grade 11. So it's a grade 11 course in Canada and in US also in general. So let me just share with you a whiteboard and we'll begin from there. That should be good.
Okay.
Okay, so you can see my screen, right?
Yeah.
Good. So let's begin with inverse function. Can you tell me what is an inverse function?
It's like the opposite of a normal function. For like you replace y with x and you solve.
Replace y with x and then solve. So basically, if you practically look at it, so what really happens is that normally when we do write a function, we say, well, this is our x-axis, that is the y-axis, right? So in
Yeah.
function notation, we write this y as equals to f of x. You get the idea, right? So
Yeah.
f of x becomes the y. So for example, your parabola, if you want to sketch some parabola, so it could be, let me just simply draw one which is kind of x squared, and this is your function. So this function, basically, you could write this as, let us say, x squared. We'll keep it very simple. So that is the function. Now, when I say inverse, so what basically we are doing is, we basically, instead of having x as the input and y as the output, so this is your in, and that is your out. What we are trying to do now is do the reverse, and that is, if y is my in, then x should be my out. Then it is a function. Is it okay?
Yeah.
Now we also learned that in case of a parabola, since it fails the horizontal line test, it is not a function, right? Inverse is not a function, correct?
Yeah.
So if I draw a horizontal line, so it fails, correct? So it means inverse is not a function, since it fails horizontal line test. So we are just doing a quick review of what you learned and where we left. So this is where we left, actually. Since, if you find the inverse of this, then basically, how will it look like? It will look like something like this. Let me just draw some approximately. Okay. It will look like something like this. Do you see that? Now,
Yeah.
this is not a function, since you see, if I draw a vertical line here, then what really happens? If I draw a vertical line, for example, it crosses at 2 points. Okay? So
Yeah.
the inverse fails. So this is not a function. When I say inverse fails, it really means what? Let's take a value and understand. So let's say I have a point here, which is, let's say, 2. And what is square of 2?
4.
4. So I'm saying that I have a point 2 and the output is 4, since my function is f of x equals to x squared. So square of 2 is 4. But now, if I put 4 as the input and go towards the reverse side, that is to say, let me just use another different color and then show it to you. Okay. So if I put 4, then basically I could go either side. Do you see? For 4 going backwards, I could hit on the left side and reach -2, or I could hit on the right side and reach 2. So basically, if 4 is my input, then what I see is that I could get either the output of -2 or of 2. I'm not sure about it, correct?
Yeah.
There is an ambiguity, and therefore inverse is not a function. Now, how can we ensure that for y equals to x squared, inverse could be a function? Can you tell me one of the techniques?
You can restrict the graph.
So restrict the function.
Yeah.
You could restrict the domain or sometimes the range. So we'll restrict the domain to x greater than equal to 0. Do you see that? So if I restrict greater than equal to 0, I'm only working on the right side of the parabola. Do you see that?
Yeah.
So in that case, we know it is a function since now we are specifically looking at the value of 2, not -2. You get the idea?
Yeah.
So that is the whole concept. So what we have learned here is that inverse of a function may not be a function. Do you see that?
Yeah.
Only if you have one-to-one function, then inverse is also a function. Clear? Okay. So this is absolutely clear. We learned here that inverse may not be a function. If inverse is not a function, we could restrict the domain or even the range sometimes to ensure that the inverse is a function. Is it okay?
Yeah.
Many functions, many relations inverse could be a function. We could have some relations like a circle. Restricting, we can make it a function. You get the idea?
Yeah.
So we could do like that also. But strictly speaking, when we say inverse of a function, we mean one-to-one function only. Do you understand? Otherwise, inverse will not be a function, correct? So you're talking about parabolas, and if you say inverse is a function, you have to restrict the parabola, correct?
Mm-hmm.
So now let's take up some examples based on this and then move forward. Another important thing is how to find inverse. Can you tell me the techniques learned? Technique 1, how do you find inverse? Tell me.
You can do words.
By words. Very good. Example. Let me write down a function y equals to 2x minus 1. Tell me the inverse. This is f of x, correct? And I want you to give me f inverse x. And that is how we write it. Yes, tell me.
F inverse x is x plus 1 over 2.
Plus 1 over 2 is very good. So 2 times x take away 1. If you go the reverse order, which is from here, what we do first? Add 1 and then we divide. So add 1 and then divide by 2, you get your inverse. Very, very beautifully given the answer. Now here is another example for you. This is slightly tricky. So we have this function f of x as equal to 2 times x minus 3 whole square minus 5, where x is greater than equal to 3. Now tell me, what is the inverse of this using words?
F of inverse x equals x over 2 x over 2 plus 3.
That is wrong, correct? Okay, let's look into it. Let's look into it. Wait. If you see, what is the operations being performed? 2 times x minus 3 whole square plus 5. So practically, if I put x as equal to, let us say, if I put x as equal to I want to take a value which is easy to calculate. Let's say 4. Is it okay?
Yeah.
So what will I do? I will first put 4 in the position of x, and then I will first calculate. I will do 4 minus 3 and then square. Do you see that?
Yeah.
I am doing 4. So first what I do? First I do take away 3. First I do take away 3 and then I square. And then I times by 2. And then I add 5. Is that clear to you?
Yeah.
So when I have to go backwards, I will do just the reverse operation. So the reverse operation will be that to the x, I have to first add 5 because I'm starting from here, right?
Yeah.
So, I mean, this was, sorry, minus 5, minus 5. So when I go from this side, I have to do the reverse of this operation. So we are doing reverse operation. In words. So in words, I'm going to add 5 to it first. And then I'm going to divide by 2. And then I'm going to square root it. I'll check about the sign later. And then I'm going to do plus 3. Since we are given that x is greater than or equal to 2, that means we're looking into this part of the parabola, which is the right side, whose inverse will be that part of the parabola, right?
Yeah.
No, this part, not this, because that will correspond to this part. You get the idea? Plus.
Yeah.
So we have to use plus sign here, since we have used the plus. This is one way of checking. The other way of checking is very important to understand, is what is the domain of this function? Well, for this function, domain is that x is greater than 3, right? And equal to
Yeah.
3. And the range is y value is greater than or equal to minus 5, correct?
Yeah.
So as soon as you want to do the inverse, you have to write domain and range first. So I prefer to write domain first, which is now the range of the previous function. So domain will be x greater than or equal to minus 5. Do you see that?
Yeah.
And the range will be y greater than or equal to 3. So you see, when I say greater than or equal to 3, I know I'm looking for other part. So here, I will add to this that x is greater than or equal to minus 5. You see that?
Yeah.
Because that is my domain now. So you just swap x and y values to get the domain and range, and that helps you to write down the correct answer for the inverse in any case. Either you do by words or by any other method. Is that clear to you?
Yeah.
Very quickly, you have answered first, which is find inverse by words. I'm going to erase the screen and then we'll do the second technique. And what is the second technique to find inverse?
Algebraically.
Algebraic, okay. Let me take different kind of an example. We have y equals to 2x minus 3 over x plus 5. How will you find algebraically the inverse of this function?
So first you multiply each side by x.
First, you want to write x and y and then isolate, right?
Yeah. So
Let me swap
get
it. Let me swap.
x.
So first
Okay.
is we'll swap. So x equals to 2y minus 3 over y plus 5. And now you will do what you said. X times y plus 5x equals to 2y minus 3. We need to isolate y, correct? And therefore, we will say, well, let's bring these things here. So we have 5x plus 3 equals to 2y minus xy. Now, we have 5x plus 3 equals to y is common, right? So we have 2 minus x, y is common. And now from here, y can be isolated and written as 5x plus 3 divided by 2 minus x. Is that clear to you?
Yeah.
At times, we may write this inverse as minus of 5x plus 3. Since the denominator, we would like to write x first. You get the idea, right?
Yeah.
X minus 2. So that becomes the inverse of this particular function. Is that clear to you?
Yeah.
As an exercise, can you find domain and range of this particular function first?
Okay.
Right, domain and range of function f of x.
Is the domain -5 and the range is 3?
Okay, for range, it is all real numbers except one point, which is the horizontal asymptote in this case, which is ratio of 2 and 1, it is 2. I'll teach you how do we find the horizontal asymptote soon. Is that okay?
Yeah.
Now, since we figured out the domain of the function and the range of the function, now we can write down domain range of the inverse. It will be the range becomes the domain, right? So it is x belongs to real numbers, but x is not equal to 2. Is that clear to you?
Yeah.
And as far as the range is concerned, it will be y belongs to real numbers and y is not equal to -5. Clear?
Yeah.
So that is interesting function, rational function we just did. So we have already covered linear, quadratic, and now the rational function. Okay, let me teach you how do we find domain. Just a quick note on the side, and then we'll move on to the third technique of finding the inverse. Clear?
Yeah.
So far, do you have any questions?
No.
Very good. Let's move on. So let's see, how do you find horizontal asymptote? We have the function y equals to, let me write any function, right? Let's say 2x plus 3 over 5x minus 4, correct? Horizontal asymptote is the value function f of x is approaching when x approaches positive infinity or x approaches negative infinity. If the value is real, then the horizontal, so we say value. Normally we'll write L. So if the value is L, right, which a function is approaching when x approaches, then we say that horizontal asymptote will be y equals to L. Is that clear to you?
Yeah.
Now, how do we find this value? So we are saying x approaches, let's say positive infinity for now. Is it okay? Infinity is a very large number and 1 over infinity will approach 0, correct? So that means, right? So we are taking advantage of 1 over infinity is approaching 0 and x approaching infinity. That's what it means. So how we do it is, let us factor x out, right? So if I factor x out from the numerator, I get x 2 plus 3 over x. Do you see that? In the denominator, when I factor x out, I get 5 minus 4 over x. Is that clear to you?
Yeah.
Now, you can cancel the two x's which have been factored, and therefore, you could simplify and write this as 2 plus 3 over x divided by 5 minus 4 over x, correct?
Yeah.
Now, what happens when x value is approaching infinitely large value? It could be positive or negative. In that case, you can see that 3 over x approaches 0 and 4 over x also approaches 0, correct?
Yeah.
Therefore, I can write y as equals to 2. I can approach 0. I'm just writing 0 for that. And 5 minus 0. I approach a value which is 2 over 5. Do you see that?
Yeah.
So we can say over here very clearly that when x approaches infinitely large value, then y is approaching a value which is 2 over 5. Do you see that? How we found the horizontal asymptote? So we say that the horizontal asymptote for the function is y equals to 2 over 5. Now, if you look into the equation, it is this ratio. Do you see this ratio 2 over 5?
Yeah.
So now here, if same degree, of numerator and denominator. Then horizontal asymptote is y equals to ratio of leading coefficients. Is that clear to you? So 2 is the coefficient of x, 5. Both are degree 1. So it's the ratio 2/5. So easily we can find if we have this, correct? Now, if the degree of denominator is higher than y equals to 0. So let me just write down here, if degree of denominator is higher than y equals to 0 is horizontal asymptote. Is that clear to you? Yeah. So because degree is higher in the denominator, when you x approaches infinity, the denominator approaches infinity, 1 over infinity is 0. Makes sense, correct?
Yeah.
So is this part clear to you? Given a rational function, how do we find domain and range? And therefore, we can also find domain and range of the inverse of the function. Clear?
Yeah.
As an added exercise for you, you have to find domain and range for these two functions. Is it okay?
Okay.
For both function and its inverse. So we're going to, can I clear this? Is this all clear to you?
Yeah.
Good. So let me just clear this. And we'll now move on to the third method of finding inverse. What is the third way of finding inverse?
Coordinates.
Very good. So you remember almost everything. Let's say we have a function f of x, which is given to you a set of points. Let's say 2, 3, 3, 4, 5, -2. Let's say 1, 1. Okay. So what is the inverse of this function? Just flip the points. Is that clear to you?
Yeah.
Now, what you notice here is one point is common in both, right?
Yeah.
We call this as an invariant point. Since it is common to both function and inverse of the function. Is that clear to you? Invariant does not vary. Is that so? Any point of the form a comma a will be invariant. Is it okay?
Yeah.
Now, the inverse is a function. Clearly, we have seen that the domain are all distinct, right? So they are not repeating, and therefore inverse is also a function for this particular case. Correct?
Yeah.
Easy. Now, let's take the fourth method of finding inverse. Can you tell me, please, what is the fourth method if we are given a graph?
Like you find you reflect it over the like
y equals to x, which is the diagonal line. A very important technique. You could easily do it. Let's take an example here also. But this is kind of combination of what you did just now, which is coordinates flipping, right? You get the idea? So it is like this. And well, so now I'll show you a technique. We'll just draw any graph. Okay, so let's say we have a graph here. Okay. Now I have to find the inverse of this function. So what I do here is that I draw a line which is y equals to x. Do you see this line which is y equals to x? Now, I have to basically flip the graph. Now, the graph could be very complicated. You may not be in a position to read the coordinate points as they are fractions and things like that. So, in that case, you cannot find x and y value. And you're just given a graph without any coordinate points, right? Blank graph like this. Maybe we just write here 1, 2, 3, and 1, 2, 3. But, it's not very easy to read the values. Now, what should you do? You could flip the graph on the line y equals to this. So we'll reflect the graph on this line. Now let us see. We are given a graph paper, of course. We'll first mark the invariant points, the points where the graph crosses the line y equals to x, right? So mark invariant points. Our inverse is going to go through these points. Now, second part is identify some good points. Like this is going to one extreme, right? So we'll just come diagonally and we'll say, well, that is my image, right? And here also we have this, and this is my image. So I go diagonally, and then I figure out this is my image. Okay, sorry, I did the other way. So from here, I'll go this side and say that is my image. Is that okay? And this is invariant. And here I can say, well, that is my image. You get the idea? I got some image points now. Is that okay? And
Yeah.
here I identify an image point. Do you see that?
Yeah.
Now, I just need to connect these image points to get my graph. Is that okay? Oh, sorry. So I'm going through the invariant. I'm going through the invariant, connecting the image. Is that clear to you?
Yeah.
See how easily I have sketched the inverse of the function. Is that clear to you?
Yeah.
So check inverse. So find image of inverse, image of some critical points by reflection on y equals to x. And then you connect them. Is that clear to you? Sometimes you have to ask, they might give you some statement saying the function has got this domain, that range. How do you find inverse of this particular function? Is that clear to you?
Yeah.
Is this absolutely clear? 4
Yeah.
methods of finding inverse. Depending on the situation, use the one which is best for you. Correct?
Yeah.
Beautiful. Now, on inverse function, what really a function which we are going to take now is square root function. So we are taking some test examples. And we are doing square root function. So I'll just give you a general graph of square root first to begin with. And we'll say, well, that is my graph, square root x, right? Correct. So as you see, the square root function is most restricted. I mean to say the domain is of the function only on one side, which is x is greater than or equal to 0, and range is also. So it is in only the first quadrant, correct?
Yeah.
Also, what we notice about this is that it is always increasing. And it is positive. Is it clear to you? Now, from these characteristics which we just figured out, if I'm trying to find inverse of this, right? So if I'm doing inverse of this function, can you list the characteristics? Very important communication question from test point of view. So for a square root function, what are the characteristics of its inverse function?
It won't be restricted.
It will be restricted. However, so domain and range will flip, right? So basically, you see your domain now will be x greater than 0. So it remains same in this case, right? And the range is, because even if you flip this, correct, it is greater than or equal to 0. Is that clear to you?
Yeah.
That is first thing. Second thing we say, always increasing. So if it is always increasing, then the inverse will also increase, or it will increase, right? What do you think?
I think it's gonna increase. It's the same domain and range.
It will be increasing always,
Yeah.
right? So important characteristic, and it is always positive. So inverse we feel because we are basically reflecting it on a line which is y equals to x, correct? Do you see that? So if I reflect it on this line, what do I get? I get something like, oh, sorry, I get something like this, like a parabola first leg, right? You
Yeah.
see always increasing in first quadrant. So all these things are very important to understand, figure out, visualize, right? So we are visualizing, correct? And it's always a function as you have seen. And definitely it will have some invariant point, which we can figure out is 1, correct? Because it has this point 1, 1, correct? Perfect. So that is overview on the square root function. Now, here is the test question for you. Let me erase this. I'm writing the function, which is, let's say, half square root of 2. Okay, let me give you a simple. X minus 5. Okay. Well, let's add some. Plus 6. Now tell me, which technique will you use to find the inverse of this function, and how will you find the inverse of this particular function?
Think you can do it algebraically?
Yes, you have to do it algebraically. Good job. Okay. I will recommend, even before you start, figure out domain and range. You get the idea? And
Yeah.
so write down domain and range for both function as well as its inverse. Now for the function, can you tell me what is the domain of this function?
X is greater than or equal to 5.
Correct. So that is how you calculate. So you know x is greater than or equal to 5 because within the radical sign, I cannot have a negative number. It has to be non-negative. And then it is increasing. It has translated 6 units up. And therefore, we know y is greater than or equal to 6. Since we know this, we will first think, write down here that the domain is x is greater than or equal to 6. Do you see that? We have flipped it. And y is greater than or equal to 5. Is that clear to you?
Yeah.
Of course, all real numbers, everything you should write. Okay, using proper notation, right? So first characteristics, very important. We have clear idea of how our function is going to look like. Now we'll do the algebraic method. So swap. So we have x equals to half of square root 2 times y minus 5 plus 6. Tell me, what operations are you going to do to isolate y?
First you subtract 6 on both sides.
Correct.
And then you multiply each side by 2.
Correct.
And then you square root each side.
Square.
I mean, a square.
Yeah. And then
you divide each side by 2.
let me rewrite. Let me have more space here, right? So first thing is you said x minus 6, and then you said multiply by 2 in this case, and then you said we have to now do the square of this. So you're doing the reverse operation beautifully. And then you're left with 2 times y minus 5. So you're definitely multiplying by half, correct?
Yeah.
And then you're going to add 5, and then you're getting the value of y, and then you're going to write down the answer. F inverse of x is equal to half of x. I should write 2 first. That's the way to write. Okay. Let me write insert 2 here. 2 times x whole square plus 5. Is that clear to you?
Yeah.
As soon as you write this function, and if you do not include domain or range, then your answer is incorrect. So as soon as you write, also write comma, x is greater than equal to 6. Now we have a function which is inverse of the given function. You get the idea?
Yeah.
If you do not write this, then that really means you are talking about a parabola which will be going up like this, right? But no,
Yeah.
we are not talking about this. Our function is and should be only the right side of this parabola. Is that clear to you?
Yeah.
That's the key. So if you miss here, you lose 0.5 marks. So therefore, I will suggest start with domain range, ensure that the domain of the inverse is clear to you, then do the calculation and include the domain in your answer. Correct?
Yeah.
Good job. So once you do all this, you can easily sketch also. Now, I will have another topic which is related to inverse. We found invariant points, correct?
Yeah.
Now the idea is, can the inverse of the function be same as the function? Can the inverse of a function be the function itself? Yes. Can it be? If so, you have to give examples. Very good. Well, clearly, the question indicates that there are functions which are self-inverse. So we call them as self-inverse functions. Can you quickly tell me 3 of them?
Y equals X.
Very good. So first function is y equals to x. You just swap, you get y equals to x, correct? It is the diagonal on which you are reflecting. Everything is invariant, correct? Very good. Now second function.
X equals Y.
X equals to y and y equals to x is the same thing. Okay, smart. Anyway, you got the second function, but it's y equals to x. You get the idea.
Yeah.
Any other function. If I want to make one line which is inverse of this function, how could I draw the line which will reflect on itself? How about a line which is perpendicular to this? Think like this.
Y equals negative X.
Y equals to negative x. Yes, because that will reflect on this. Y equals to negative x will, however, go through this line. Is that clear to you? But
Yes.
even if y equals to negative, mx will be a general line which will reflect on itself because the line is perpendicular to y equals to x, right? So it will reflect. So these points will come there and these points will move there. You get the idea?
Yeah.
So that is a very beautiful function, and you can create any number of functions with just y equals to negative, right, value of x. So m is negative. So m value could be anything. You get the idea when I write minus, right?
Yeah.
It is actually the same line. It's not the reciprocal, parallel, perpendicular thing, correct? So what I'm trying to say is, if I have y equals to, let's say, 2x, minus of 2x, that means that it is not, oh, sorry, I should not write, sorry, wait, I'm sorry. Y equals to minus x, sorry, minus x plus k. Y is, sorry. So let me just erase this a bit. I wrote it wrong. So, okay. So what I'm trying to say is y equals to minus x plus k. Is it okay?
Yeah.
Now, these are all the lines which are perpendicular to y equals to x. And therefore, they will reflect on itself. Is that clear?
Yeah.
So that is one function which is inverse. Now, can a rational function be inverse of itself?
I don't think so.
Okay, try this. Y equals to 1 over x. It will be same, right?
Oh yeah, yeah.
Yeah, it is. Or y equals to minus 1 over x. So we also see that the reciprocal function 1 over x or minus 1 over x also reflects on itself. So there are many examples which fit into this category of self-inverse functions. Clear?
Yeah.
Now I'll share with you a test question based on this. Right? Okay, let me search my videos on this and I'll say, okay, so I'll stop sharing the screen and we will go to my YouTube channel and then I will, okay, so Anil Kumar, inverse function playlist, right? So let me just, okay, we want self-inverse, right? So there are many inverse videos on inverse function. For Anil Kumar, self-inverse function. Self-inverse function, right? So if you type this on my YouTube channel, what do you get? Let's see. Okay, there are many functions which we are talking about, but I am more interested in the rational function. You get the idea. This is a rational function, right? Let me click.
Yeah.
Okay, so there you go. Can you please read the question? Okay. Great. I need you to answer the question, okay? So
Okay.
let me just go to the beginning of this video. We're talking about which inverse, self-inverse, right? So there are many videos in this, and I've purposely taken rational functions as that sometimes is more difficult. Here's a very beautiful technique which I can discuss with you later. I'll discuss that also. You go through this video, you learn many things here, okay? So I'm sharing many other techniques of how to work with rational functions, as many students find it difficult. And since you are working only on quadratic functions being in grade 8, well, even that is a big thing. For you, this reciprocal or rational function is a challenge, right?
Yeah.
Now, can you tell me, answer this question. Read the question first.
I can't see your screen.
Oh, is it? Oh, sorry. Okay, let me share the screen. Okay, so what I did, share. Okay, share the screen. Okay, there you go. So I just searched my playlist and I found one. There are many, but this one is a very good question based on self-inverse of a rational function. Can you please read this question?
Which of the following rational function is a self-inverse function?
Multiple choice. Tell me, which is the right answer? How will you figure this out? You can try one by one all the questions and get the answer. You could do that, correct?
Yeah.
Yes. That is one way of doing it. What could be the other way? Because multiple choice test question, it takes, a limited time is there. And if, let's say you start with the first one and fourth one is the right answer, you will spend all the time just for, 1 or 2 months. So we need to come out with a more efficient way of finding inverse, whether it is a function or not. Is that clear to you?
Yeah.
Correct. So how could you do it? Okay, find inverse of the first function and see what do you get. And
Okay.
Yeah.
Okay, I got for the first one, I got x minus 2 over 1 minus x equals y.
So that is not inverse, right? Self-inverse. You go for the first one, you got x minus 2.
Yeah.
So try the second one. Mhm.
I can't see it. I went to another video.
Yeah. Yeah, I clicked something that was. So we'll just search again, okay? Don't worry. So when you search Anil Kumar's self-inverse functions, you see many functions. And this is the one which I was showing you. So let's look into this now. Okay, so here, there you go. I've stopped the video from running now. And we'll figure this out. So, so first one you found is not a self-inverse, correct?
Yeah.
So you can try and you'll figure it out. But see the technique which has been used here. So one thing is you could take a point, right? You could take a point, which is trial and error method. You see that? So what I did here was I've taken x value as 0. Easy to calculate, correct? So if
Yeah.
x is 0, then what is y? So when I put x as 0 in the very first one, we get y as equals to 2, right?
Yeah.
2 over 1. This calculation was wrong anyway. So, and when I put 2, then what do I get? That is what you will not get the same thing, right? So you
Yeah.
have to get the same value basically. Is it okay?
Yeah.
So now with 0, in the second case, what in part C, when I put 0, I get 2 over minus 1, right? I get minus 2, correct?
Yeah.
Now, if I put minus 2 here, then what do I get? Substituting minus 2, I get 0. You get the idea? Getting
Yeah.
back 0. So with 0, I got 2. And then when I plug 2 in, I got 0. That means it has the point 0, 2, 2, 0, correct?
Yeah.
So one point will match the other one, and therefore it becomes a self-inverse function. Is that clear to you?
Yeah.
So substituting a point for a multiple choice question is probably the fastest way of finding the self-inverse in such a scenario. Is that clear to you?
Yeah.
Right. So that's what we should be doing, and so we found that this is the right answer. Now, this is also a general formula. So if you watch the video, you will understand that this becomes a general formula of finding the inverse for a rational function. And this is what I'm doing on the next page. Do you see this particular page?
Yeah.
What I've done here is I've taken a function which is y equals to x plus a. We are not doing any calculations, trial and error now, right? We're talking about algebraic method. Is it clear to you?
Yeah.
So I saw that this is like x plus something and in the numerator and all. So I wrote x plus a and x plus b. The idea is I should get coordinate which is kind of c, d, and dc, correct? This is what I want, right? So when you want to find the inverse, see the method. So I have x and y. So x equals to y plus a divided by y plus b, cross multiply. X times y plus b is y plus a. Bring the y's together, that's the process. And so you get y times x minus 1 equals to minus bx plus a. And then isolate y, dividing minus bx plus a by x minus 1. And you get your inverse function, which is shown on the right hand side, correct? So you get y equals to f inverse of x. And now clearly, you want these two things to be same. Inverse means the function should be same as the inverse. So x plus a divided by x plus b should be equal to what? Minus bx plus a divided by x minus 1, correct?
Yeah.
So what value of b will satisfy this relation? Minus 1. You get the idea?
Yeah.
So if b is minus 1, b is what? B is in the denominator. And we want x minus 1 in the denominator. So only equation C has got -1 in the denominator. Is that clear to you?
Yeah.
And therefore, that becomes your answer. So next time, if there is a question on self-inverse of a rational function, which is like this, you can say, well, x minus 1, if it is there in the denominator, whatever you write in the numerator, linear function like this, correct?
Yeah.
That should be the inverse. You get the idea.
Yeah.
So that is how you will do it. And so we have learned strategies to answer multiple choice questions. Substituting point and understanding what really inverse is a good method. And second is general solution of the equation itself. So equation is of the type x plus a divided by x plus b. Find the inverse of this equation. You get this as minus bx plus a over x minus 1. And now equate original equation with its inverse and then figure out what value works for those two should be same. And clearly, in this case, it is b equals to -1. Is that clear to you?
Yeah.
Perfect. So you should mark this. Now, when you're watching my videos, you can also type Anil Kumar self-inverse functions test. You get the idea. I have 10 years of test papers on my YouTube channel. Questions here and there, okay? So these questions which you are looking are actually picked from previous test papers. So this show that this is inverse of itself. Do you see that?
Yeah.
We also hit a question which is, can you please read the question?
Show that f of x equals minus x minus 2 over 5x plus 1 is inverse of itself.
Do you see that? Here, nothing like b equals to -1. It is x has now got coefficients which are not 1. In that case, that rule will not apply, correct?
Yeah.
Horizontal asymptote here is not 1. So now, in this case, you have to do all that juggling, algebraic operations, and then show that this is inverse of itself. You see that? So there could be many functions. Now, let me just search some more. I would like to show you one or two test papers. So we just saw some self-inverse general solution strategies, multiple choice. So once we could have many questions based on it. Well, so it's kind of a similar question which we just worked on. Okay. Because that was a test problem. So you might see this question in a couple of places. Well, here it is a self. Oh, I wrote self-inverse. That is why. Okay, let me remove self-inverse now. So inverse function test. That is what we are interested in finding. So now, do you see this? If the inverse of this function is that, you read the question. Another very beautiful question before you. So we are given inverse of the function and you have to find the coefficients in this particular case. Now, the question purple. Do you see these questions here?
Yeah.
So these are true or false questions on inverse function. Very important questions from test point of view. And here, the question number 4. Can you please read question number 4?
Okay. Inverse function of f of x equals x, and f of inverse function of x equals x.
Does it make sense? Is it always true? So basically, if you put the input, you get the output, and if you put the output in, you get the input, which is x. You get the idea. So that is the basic definition where it is a one-to-one function. So if it is one-to-one function, right? So in that case, the statement is always true. So many times we give you a function, we give you inverse of a function, and we will tell you, find or prove that one is inverse of the other. You can find function of function equated to x and get the answer. This is that technique which we have discussed just now. A very important question from test point of view. You get the idea?
Yeah.
Question number 3. Can you please answer question number 3?
Okay, inverse of f of x equals x squared plus 2x minus 1. X is greater than or equal to negative is y equals square root x plus 2 minus 1.
Correct. Are these inverse of one another?
No,
How do you know?
because it says when you instead of adding one, they subtracted one.
Correct. So it is not it is not completing the square. It is a standard equation. So you may have to write this in the completing the square format and then apply your technique. You get the idea. Directly from here, you cannot do it. So you know the ways of finding completing the square. Do that first and then find the answer. Correct?
Yeah.
Okay. So you can go through my videos on this. We'll end the class here. Is that okay, Abhinav?
Yeah.
Can you summarize today's learnings?
Okay, so first we read on inverse functions and the 4 methods on how to find them, which are words, algebraically, coordinates, and using a graph and reflecting it.
Right.
And then we went into self-inverse function and how to determine if function, the inverse function is self-inverse function, and the different methods.
Yeah.
And then we did some practice on it.
Sure. And function of its inverse function will result into x, correct? If it is bijection or one-to-one function. Clear? Watch some of my videos from the YouTube channel. You'll learn a lot. And if there is any difficulty, feel free to post your questions. Okay?
Okay.
Okay then. Enjoy your holiday. Thanks.
Okay.
Have a great day. Bye.
Bye.